there we go. All right. 5.1 is all about triangles, and it's a very, it's an introduction to triangles. So we want to be able to do three things today. Classify triangles by their sides and by their angles. Use the triangle angle sum theorem to help us find a missing angle in a triangle. And then, that's not a complete sentence, use the, it's the exterior angle theorem to find a missing exterior angle of a triangle, or to find a missing interior angle, depending on what you're given. So that is where we are headed for today. So grab whatever you're using to take notes. And while you do that, in the chat, what are some triangle vocab words you remember from other years in school? Do we remember any triangle vocab from previous years? What are some words we remember involving triangles? It can be anything involving triangles. Acute, obtuse. Nice. Those are good words. We will be using those today. (180°). That's another thing we'll be using today. Isosceles. Yes. Right triangle. Yes, these are all good words we will be using and refreshing our memories on today. Nice. That covers a lot of the main words that we're going to use. Okay. So we're going to jump over to notes. And today is 5.1 notes. We're talking about triangles. Okay, so there are two main categories when we classify a triangle that we're going to be asked to talk about. One of the ways is when we're talking about the sides of a triangle. So if I ask you to classify a triangle by its sides, there's going to be three main words that we use to talk about a triangle using the sides. The three words are equilateral, isosceles, and scalene. Okay, so equilateral, well, it has the word, a variation of equal in it, right? And then lateral is for sides. Equal sides is where that comes from. So that means we're going to have three congruent sides. Three sides that all have the same measure. And remember, our notation for segments that are the same length is a line, like a small hash mark in that segment. So that would show me that these three segments are all the same length. That's what we're picturing when we see equilateral. Three congruent sides. Okay, then isosceles is at least two congruent sides. All right, at least two congruent sides. So an equilateral triangle is technically also a special case of an isosceles triangle. An isosceles, we wouldn't typically call it isosceles, and we want to classify it by the most specific name typically. So an isosceles triangle, we might see something like this, where two of the sides are the same and one of them is different. So at least two congruent sides. Okay, and then the last one, scalene, is the third option, no congruent sides. So we might see something like that where all three sides are different. Okay. So that would be classifying a triangle by its number of congruent sides. Okay. The second way that we're going to be asked to classify a triangle is by its angles. And we're going to have 4 words to talk about a triangle using its angles. So we have acute, we have obtuse, we have right, and we have equiangular. And you can't see those. Acute, obtuse, right, equiangular. Okay. So for acute, that just means we have 3 acute angles. So all 3 angles are acute. So we might see a triangle like that, where all the angles appear to be less than 90 degrees. Okay. Obtuse means we have 1 obtuse angle. So we might have something like that where one of the angles appears to be greater than 90 degrees. A right triangle means we have 1 right angle. And typically this angle will be called out with that right angle corner in the picture. All right, and then lastly we have equiangular, and an equiangular triangle is going to have 3 equal angles. And all of those angles will be acute, and we'll talk about exactly what those angles will be in just a moment. Three equal acute angles. Remember, that's our symbol for angles that are the same, having 1 arc in the angle on each of those. That means those are all 3 the same angle. Okay, so now we have words to talk about triangles by their sides and by their angles. So let's do a couple of examples of questions you might see. We might be asked to classify the triangle by sides and angles. So we might be given a picture like that. Okay. So first, going off of its sides, what do we think? Does that triangle have any that are the same? Is it going to be equilateral, isosceles, or scalene? And go ahead and type in the chat for this one. What do we think? Yes, you're right. Oh, and it is scalene. This one has no sides that are the same. And remember, in order to assume that things are the same, they need to be labeled as the same. This would be scalene. So just because they're not all labeled as particularly being different, doesn't mean we can assume any of them are the same either. All right, and then what kind of angle do we have here? What would we classify this? How would we classify this by angles? Yep, we have one right angle going on here. So this would be right as well. So the words we would use to describe this one would be scalene and right, and then we would be done, because we've classified it by its sides and by its angles. Okay. Or we could have something like this. All right, so how would we classify this one by its sides? Well, we have two that are the same, right? So two that are the same, we look back up at our notes and go, oh, two that are the same is, yes, isosceles. Nice to meet you. What do we think for angles on this one? Are any of these angles 90 or greater? I don't think so. Yep, this one's going to be acute, because all of these angles look like they would be less than 90. Or at the very least, none of them are labeled as being 90. And none of them look greater than that. So this would be isosceles and acute. Okay. We'll do one more. What do we think for this one? Classifying it by its sides. Just like the last one, we have two that are the same, right? So that'd be another isosceles. But this time, these are not the same kind of angles in both of these triangles, right? This one here looks obtuse, and so only one obtuse angle is required in order for it to be an obtuse triangle. So this would be, yeah, obtuse. So this one is isosceles and obtuse. Okay. So that's classifying a triangle by its sides and by its angles. Also, something to note, if a triangle is equilateral, it is also equiangular. So anytime you see something where we have equal angles or equal sides, the other one is also true about that. So if I see equal angles, oh, come on, computer. There we go. If we see equal angles, we also know that equal sides happens. If we see equal sides, we also know equal angles will happen. So those two things coincide. Okay, so that's classifying triangles. Now we're going to start actually talking about angles in a triangle. And I think it was Nolan that mentioned 180 degrees. That's going to come up big here. Okay, so the first thing we want to talk about is the different classifications of angles in a triangle. So first, we're going to talk about interior angles. cleverly named. They are the angles that are inside the triangle. So this is an interior angle, this is an interior angle, and this is also an interior angle. Also, as we've seen in previous units, typically the angles are labeled. The vertices on a triangle, those corners, are labeled with a letter. So this would be A, B, and C for those corners, for those vertices. So those are the interior angles. And then triangles also have exterior angles. And so what we mean by that is if we have a picture like this, you can still have, you know, A, B, and C. We're going to talk about exterior angles here. Exterior angles are the angles that are outside the triangle, like right here, here, and here. These would be exterior angles. Okay. So we have interior angles, we have exterior angles. So let's talk about interior angles first here. With interior angles, there's something that's important on triangles. It's called the triangle angle sum theorem. Triangle angle sum theorem. And it's a fancy way to say something very simple. And actually, in order to illustrate this, if you have paper there with you, if you have like notebook paper or something like that, go ahead and grab a piece of paper out of your notebook. And we're going to tear off one of the corners to make a triangle. So I'm going to do the same thing here. I'm going to tear off a corner to make the triangle. If you have scissors and want to use scissors to cut off a corner of your paper, great. If you don't have scissors and you want to just fold it back and forth a little bit to tear off the corner, you can do that. All right, we're going to do our very best to get a good triangle going here. I tore off the corner. That's not great. Or the corner I didn't want to tear off. Okay. Let me try this one more time. That's better. All right. Okay, so here I've got a triangle going, and here's what I'm going to do. I'm going to take my corners, and I'm going to color them in. All three of my corners. Because we are going to illustrate something here with this. Okay, So if you have a triangle like this and you can color in all of your corners, great. If you don't have a triangle, like you don't have some notebook paper that you could tear off and get a triangle from, that's okay. You can just follow along with my illustration here. So what we're going to do is I'm going to flip it over so that the side without the colors is showing. And I'm going to take each of these corners and fold it down to the longest side. I'm going to fold that there. And I'm going to fold this one in so that it matches up with it. And then I'm going to fold this one in so that it also matches up with that. So we end up with something like this, that our triangle was originally all unfolded. And now they're all folded in to one side. Notice how together along this line, these three angles make up that whole line. What do we think those three angles are going to add up to if I were to add them all together? What angle makes a straight line? 180. Yeah, so this is an illustration that the angles of a triangle add up to 180. And that is what the triangle angle sum theorem tells us. The triangle angle sum theorem says that the sum of the interior angles of any triangle is always equal to 180 degrees. So the sum of the interior angles for any triangle is always equal to 180 degrees. So that makes it really nice if I have a missing angle and I need to find it. So if I have a triangle here, if I was going to illustrate this with the angles here, measure of angle A plus measure of angle B plus measure of angle C is going to be equal to 180. Okay. So for example, if I have two angles on a triangle, I can find the missing one. And we can find the missing one by just taking 180 and subtracting off the two that we know. So we would just go (180 minus 82 minus 49). Which gives us 49 again. Happy accident there. 180 minus 82 minus 49 gives us 49. You can't see that. So then the measure of angle Q is 49 degrees. So that's one way we can use the triangle angle sum theorem. We can use it to find a missing angle. Okay. We can also kind of step that up a little bit. If I have a triangle here, and let's say this angle is 2x and this one is 3x plus 5. There we go. We can use it to solve for a variable. On this one, it was just a coincidence that P and Q were the same. So if this was like 42 or something, this angle wouldn't be 42. If this angle was anything else, this one wouldn't be 49. Yeah, so the idea with that one is that we do need to subtract off of 180. But yeah, good putting things together. And we will have a case eventually, not today, but we will talk about a case where we can use the fact that two sides are the same to determine that the angles across from them are the same and stuff like that. In which case you would be able to do something like using P to find Q. But that'll be for another time. So if we got a picture like this and we were asked to solve for X, or we were asked to find the missing angles, the first thing I would do here is notice that this is 90, since it's labeled as a right angle. And then the equation that we would set up is we would add all three of these angles and set it equal to 180. So we go 2x plus 3x plus 5 plus 90 equals 180. So when we're dealing with triangles, we're going to be doing a whole lot of adding to 180 or subtracting angles away from 180. So then combining like terms here, we get 5x plus 95 equals 180. And then subtracting 95, we get 5x equals 85. And then dividing by 5, we get x equals 17. So basically all we were doing here was we take angle A plus angle B plus angle C, because this was angle A, this was angle B, this was angle C, and we set it equal to 180. And then we solve for x. And if we wanted to at the end, we could take x and plug it back in. Angle A is 2 times x, which is 2 times 17 then, since we found that x is 17, which is 34 degrees. And then angle B, we could do it a couple different ways. We could go 180 minus 90 minus 34, since we now know that angle A is 34. Or we could go 3 times 17 plus 5, which gives us, let's see, 56. Yes. But if you're only asked to find x, then this is all you have to do. Okay. Any questions on either of these two? Any numbers we're not sure where they came from? Any steps we're not sure how they happened? Okay, I'm gonna have you guys try one real quick. Okay, so we have that one angle is 85, the other one is 63, and we're missing x here. Solve for x. Once you think you've got it, type done in the chat. As a couple of us start to finish up, if you did 180 minus 85 minus 63, you're on the right track. Yeah, Luis, you got it. It is 32. So if you got 32 degrees, you are correct. Okay, so that's how we're supposed to do that sort of problem, the most basic problem. The other kind, you just add all of the angles and set it equal to 180. If there's x's involved, multiple expressions with x's, add them all and set it equal to, yep, that would totally work, Samia. That's another way you could do this. You could go 85 plus 63 plus x equals 180. And that's the way that's a little bit more like this way, the harder way of doing, or the harder type of problem, kind of the one level up. And this will get you the same answer, because if you combine your like terms and subtract, you should still get 32. This is the more algebraic thinking version of this. I like it. Nice. All right. So that's the triangle angle sum theorem. We have one last thing we'll talk about, and it's involving exterior angles. Exterior angles. So remember back to the top of this page of notes here, we had these things, exterior angles here. There's an exterior angles theorem that we're going to talk about next. So it's kind of like the triangle angle sum theorem, a little bit different. Exterior angle theorem. So exterior angle theorem. Okay, so when I write this one down, it's going to sound a little bit confusing, but we'll unpack it, and hopefully it will become less confusing in just a moment. So the exterior angle theorem says the measure of an exterior angle of any triangle is equal to the sum of its two remote interior angles. Okay. So particularly the words remote interior angles are words we've not yet talked about. So we're going to talk about those and talk about kind of what this means. And remember, the sum is an addition word. So when I'm talking about the sum, I'm talking about adding these two remote interior angles together. So here we go. If I have a picture like this, and I'm going to call this angle 1, angle 2, angle 3, and angle 4. Okay. Angle 4 is an exterior angle. And we're saying that an exterior angle is equal to the sum of its two remote interior angles. So remote interior angles means it's the interior angles not touching the exterior angle. So notice how angle 3 is an interior angle, but it's touching angle 4, the exterior angle. So we want the sum of the two that are not touching angle 4. So angle 1 and angle 2 would be the two remote interior angles. to angle 4. So what this is saying is that angle 1 plus measure of angle 2 is equal to the measure of angle 4. That's what this is getting at. Okay. So that is what the exterior angle theorem says. I'll give everyone a moment to finish writing if you're frantically writing. And then we will do a couple of examples with this and then be done with notes. Okay. So our first example is going to be a simple one, kind of like our interior angle, triangle angle sum theorem question. So we want to figure out what x is. So all we have to do to figure out what that missing angle is add these two together. 54 plus 62 gives me 116. So x is 116 degrees. So that's the simple case. The less simple case is something like this. Where we get that this is 2x minus 5, this is x, and this is 70, and we want to solve for x. So now we have to set up an equation. And we want to take our two inside angles and add them together. Inside plus inside equals outside. So x plus 70 equals 2x minus 5 is the equation that we set up. And then we want to solve this for x. So I might subtract x on both sides to get 70 equals x minus 5. And then add 5 on both sides to get 75 equals x. And then we're done. Okay. So those two exterior angle theorem problems are about as complicated as they will get. Sometimes you just have to add the two angles and they're both numbers, so you're all done. And sometimes you have to add the two inside angles and set it equal to the outside angle if you have to solve for a variable. Okay, so just to kind of recap, today we talked about classifying angles by their, or classifying triangles by their sides and by their angles. We did that vocab part. Then we talked about the fact that the angles in a triangle add up to 180, and we did some problems with that. And then we did the exterior angle theorem, where you take the two interior angles and add them together and set it equal to the exterior angle. So that's everything for today. Now we're going to get to the assignment, and we'll go over a couple of problems out of each IXL section together. So I'm going to go in and assign that real quick. And then we'll talk about some of each of those together. Okay. And there are 3 sections today, but they are, a lot of them are pretty quick, especially that first one. So let's take a look at the sections that we have for today. So we have F1, F2, and F3 to a smart score of 80. The first one, F1, is about classifying triangles, so it's all about our vocab. So you'll see things like a triangle has angle measures of 22, 116, and 42. What kind of triangle is it? Well, 116 is an obtuse angle, so that means it's an obtuse triangle. Or a triangle has measures of 76, 43, and 61. What kind of triangle is it? Well, none of those are 90 or bigger, so they are all acute, so it's an acute triangle. Sometimes we'll see a picture like this where it tells you the angles of the triangle, and you'll have to notice, oh, this one's 90. That means it's a right triangle. And see, we're already at 28. Then it'll say something like, is this triangle isosceles? Now, this is the part where we do have to use a little bit of what I mentioned before briefly. If you have two angles that are the same, then you have two sides that are the same. If you have three angles that are the same, then you have three sides that are the same. That's where we had that equilateral and equiangular thing are the same. Well, if you have two angles that are the same, then you also have two sides that are the same. So this would be yes. Each of a triangle's sides measures 2 inches. Is this triangle scalene? Well, if all the sides are 2 inches each, that means it's equilateral, not scalene. So that would be no. If all the angles are the same, that means all the sides are the same too. So also not going to be scalene. Okay, so that's the kind of question that we will see on that first section. The second one is triangle angle sum. And they're going to ask you to find the missing angle. So you take 180 and you subtract the other two angles. So we would go, okay, 180 minus 93 minus 35, which gives me 52. So 52 would be my answer here. This one, we'd take 180 minus 80 minus 54, and that would give us our other missing angle right here. So that's the sort of question that we will see on the triangle angle sum. And then the last one, exterior angle theorem, is going to be this time where we take the two interior angles, 68 and 49, and add them together, and that'll equal our exterior angle, 117. This one we would add together 72 and 63, and that would give us our exterior angle. Okay, so those are our IXL sections. You are free to go and work on those. If you have questions, stick around and ask them. If you want to see more examples, stick around and we can do more examples, as many as you would like to do. Otherwise, you are free to go and work on the IXL, and I will post an exit ticket towards the end of class.